I'm very glad to be here today to give a very brief update on the workshop we just had and a little bit of status on the site selection activity. Next slide, please. Okay, so I wanted to start by giving a brief overview because not everyone may have seen some of this content, and some of these concepts are kind of difficult to work through, even for us. So I wanted to just highlight that, as most of you probably have seen this chart and will continue to see it for a long time to come, that we do have 13 candidate regions of notional potential interest for the Artemis 3 mission. And these were selected, as Noah Petro discussed in his talk at the workshop last month, by a crack team of NASA subject matter experts based, among other things, on a variety of factors. I'll get to that in a second, but you know, a number of considerations played into the selection of these particular regions, including proximity to the geographic South Pole, gentle slope for landings and moonwalks, constant view of Earth for communications, continuous sunlight throughout the surface expedition of about 6.5 days, the expected landing accuracy of a notional lunar landing system, surface data and LRO availability of LRO data availability, and in general, the combined integrated architectural capability of all the various aspects of the Artemis architecture, including the Space Launch System, the Orion spacecraft, and the Option A vehicle. Next slide, please. Okay, so mission availability is a multidimensional challenge. It's not, unfortunately, it's not quite as simple as just picking X marks the spot. Mission availability is the opportunity frequency at which the end-to-end mission can be viably conducted. So it works around actual launch days, windows, periods, the ground processing flow at the Kennedy Space Center. And so it's a really complicated mission design issue, or it's not really an issue, it's a really complicated mission design. And so we have to integrate a variety of factors, not all of which are related to one another. And then there's an additional set of constraints that must be incorporated when planning a human exploration mission, which is in contrast to pure science missions. And so this is an iterative process through design and development. And so this is, you know, we're working very closely with our hardware providers right now to understand some of these issues and where sensitivities are. Next slide, please. Okay, so the group that's charged and chartered with providing recommendations to agency leadership about the regional and site selection is the Cross Artemis Site Selection Analysis Board group, I should say, which consists of our friend Jake Bleacher, Tamara George from ESDMD, Brad Bailey from SEO, Sarah Noble from PSD and SEO, the Artemis Lunar Science Lead, and our friend Jonathan Bowie from the Space Technology Mission Directorate. This group is ably supported by a number of technical element sub-teams called technical assessment teams that are working to understand all aspects of the integrated performance of the Artemis architecture. Of note for this community, it includes science objectives assessment teams and site assessment, site availability teams, and site characterization teams. Next slide, please. Okay. So Noah discussed this at the workshop, but it's worth repeating. So all regions are located poleward of 84 degrees south latitude. This was defined by a crack team of NASA subject matter experts that leveraged heavily community documents that had already been produced by the community, including the United States Lunar Exploration Roadmap produced by League, 50 years of site selection work done for various activities like the Space Exploration Initiative, and sites that were suggested to the Lunar Surface Science Workshop #1 in May of 2020 that Jake actually mentioned. And we also have very specifically weighted factors, including the expected performance of lunar landing systems, which identify 28 candidate regions, which were subsequently down selected to 13. Next slide, please. Okay, so this will be the first landing with crew, testing new systems for the South Pole. So we will return valuable science. The recent decadal survey lays out some ambitious goals for lunar science, and we're confident that candidate Artemis sites can address key science questions. We'll get to that in a second. And the Artemis 3 Science Definition Team report, the definitive statement of mission priorities for the Artemis 3 mission, summarizes in a very lucid and readable way the science achievable at the South Pole, and offers interesting opportunities for understanding the history of the Earth-Moon system and the volatile record of the inner solar system. And so many of the proposed sites are in terrains interpreted to be some of the oldest on the Moon, which will really help us understand aspects of lunar magma ocean evolution. So that was what played into the selection of the 13 sites a little bit, or 13 regions, I should say, a little bit. And so let's get to the next part of the process. Next slide, please. Okay, so we're following an iterative process for the site selection for Artemis human landing site selections. It's a merit-based, multi-directed approach that aligns capabilities with agency priorities and objectives. And you'll note right here, and there's step 3, so we've already done steps 1 and steps 2. And steps 3 is we're looking at obtaining, applying figures of merit along with community input. And that's where this workshop we just had was so important. So next slide, please. I want to make sure I hit this. Okay, so we, as the first step in our community input process, we successfully executed the first workshop in Artemis 3 candidate landing regions on April 4th and 5th, 2023. There were 40 contributed talks. There were over 334 attendees at one point in the meeting, which was just a fantastic response for this particular workshop. And the presentations of the contributed abstracts during the meeting covered scientific aspects shared across all 13 candidate regions, including the possibilities for astrobiology, astrophysics observations, extraterrestrial economic geology, volatile storage and transport, geophysics, and basin ejecta. And there were very exciting focus sessions on several of the specific candidate regions of prospective notional interest, including Shackleton, Faustini, Haworth, the Dagerlash, Kosher, Metseef, the Dagerlash Rim, and the Malakrit regions. So it was a really, really fun meeting. And I really wanted to also express my thanks to the community. I know the timing was suboptimal, but it really was important we get it done in April. And I just wanted to thank everyone who worked hard to contribute to the meeting and show up and make it just a really fun meeting. Next slide, please. Okay, so we had some really key takeaways, and I want to emphasize that this is very preliminary. We're working on developing a more cohesive set of takeaways, which we intend to present at the survey forum later this summer. But these are some of the key, very high-level takeaways, is that from several of the talks that were presented at the workshop, that lunar lobate scarps in the South Polar region could offer unique opportunities for understanding lunar tectonism. There were some really interesting new LRO results that indicated that several sites may be crossed by rays from Tycho, which could be very important sampling locations, understanding lunar time stratigraphy, and understanding space weathering processes. There were several candidate regions conceivably contain contributions from basin-forming impacts, including South Pole Aitken and Schrodinger. The proximity to cold traps could enable opportunities to collect samples, understand volatile migration and transport processes. Even though we're not contemplating cryogenic sample return on the first Artemis 3 mission, there still could be very useful insights that will provide with profound implications for both science and the economic development and commercial operations in the system of space on the Moon, which is a central focus of national policy. And sampling materials from the polar exploration zone will really help to enable us to understand the dynamics of the lunar magma ocean. So all of these are potentially, not necessarily surprises to this community, but it's really important to get that publicly stated and have the discussion. Next slide, please. Okay, so we have some other takeaways. Is that it became very clear, again, not a surprise, that this community is extraordinarily invested in this topic. So we do intend to continue the dialogue. There will be other site selection workshops. And all the candidate landing regions offer really exciting scientific opportunities to address multiple important science objectives. So these 13 regions all seem to have value, which is really, really interesting. And a program of systematic geologic mapping to help support various aspects of parts of the mission planning process became clear that was desirable. And as Dr. Noble mentioned earlier today, there will be an Artemis geologic mapping LSSW to kind of follow up on that and the critical data products report from MapSit later this summer as the next step of that. So thanks very much.